I'm going to ask for Fitsum Tadesse from the Armal Hansen Research Institute in Addis Ababa to come forward. And Tadesse's presentation is on clustering of subpatent Plasmodium falciparum and vivax infections around patients in a low endemic setting, aiming for elimination, the Batu Dagaga Kabele in Adama Woreda, Oromia, Ethiopia.
Good morning, everyone. I would like to thank the organizers for the opportunity. Today, I'll be talking about our recent findings on household-level clustering of Plasmodium falciparum and vivax infections and genetic relatedness between infections detected within a household and between households in a low endemic setting in Ethiopia, which is aiming for malaria elimination. First, I will walk you through background about malaria in Ethiopia. 3/4 of the country is malarious, but the epidemiology of malaria in Ethiopia is a bit different from the rest of sub-Saharan Africa. It's heterogeneous, very unstable, and generally very low. And Plasmodium vivax is endemic in the country, and it contributes about half of the total clinical case in the country. And recent studies indicated that there is a substantial decline in malaria incidence and deaths attributable to malaria in the last 2 decades. And motivated by this fact, the government set an ambitious plan to eliminate malaria from selected low endemic settings. But there are challenges in elimination efforts. One of them is the heterogeneous distribution of infections, which challenge finding all the relevant infections that are contributing to the maintenance of onward transmission. And one of the options to use is reactive case detection, whereby patients are followed and their family members and neighbors are screened and treated. This helps to find more infections. So in this study, we sought to examine clustering of RDT detectable and qPCR detectable infections in households of falciparum and vivax infected index case, and their genetic relatedness, spatial and temporal, and their clustering using genetic tools. The approach we used was we followed 18 index cases, 10 falciparum, 6 vivax, and 2 mixed infection patients, and 18 controls who presented to the clinic with RDT negative malaria, non-malaria related infections. And we followed these individuals and screened their family members and immediate 6 neighbors. And in total, we screened 951 individuals in 240 households. And we screened them for RDT at the study site. And we collected dried blood spots on filter papers. And we have done qPCR, 18S-based qPCR, and genotyping analysis using 26 microsatellite markers. In the study population, excluding the index case, with RDT we found 7.7% positivity, positive asymptomatic infections, and with qPCR we detected 22.6% qPCR positivity. And among the households, the 240 households, RDT identified 28% of the households as having at least one individual infected with malaria, and qPCR identified at least 57% of the households having at least one individual infected with malaria. And self-reported history of malaria differed between the 2 communities, the community around the index case and the controls, and the fault difference was so high. And the forest plot in here indicates the odds of detecting qPCR positive infections in control households compared with index and neighbor households for each species. So what you see in here is the control household as a reference, and the index households and the neighbors of the index household for falciparum in here and for vivax in here. And for falciparum, we have seen a 2.5-fold higher chance of detecting qPCR positive infections in index households compared to the controls. And there was also a higher chance of detecting qPCR positive infections in neighbors of index households compared to the controls, even if it was not statistically significant. But for vivax, we couldn't find any household level clustering. However, when you consider all RDT detectable infections, where both asymptomatic and symptomatic, and when you see the clustering of infections, you see clustering for both species, and the effect size becomes stronger for falciparum. So in households with at least one RDT detected infection, 32% of the individuals were positive for falciparum, while only 6% of them were positive for falciparum in households without RDT detected infection. So for Vivax, we didn't see clustering when we take the index case as comparator, but in here, when we consider all RDT positive infections, we also see clustering for Plasmodium vivax. This could relate with the parasite threshold, the parasite fever threshold for vivax in relapsing episodes, which is related with malaria tolerance. And you find a lot of people in the community who carry high parasite densities but who don't show the symptoms. And what we did next was to investigate the genetic complexity and relatedness of Plasmodium falciparum infections, because the previous data indicated a strong household level clustering for falciparum. So we focused more on falciparum. So we took 92 qPCR positive samples, 55 from the RCD case and 37 from around controls. And samples were genotyped using 26 neutral microsatellite markers from 7 chromosomes. And we investigated within host and population level genetic diversity and also genetic relatedness, both spatial and temporal, and also clustering of infections. What you see in here is multiplicity of infections for the two community groups around controls and around index case in red. So higher complexity of infection was detected in the community around the index case. And we also have seen a higher level of genetic diversity, both at an individual level and at a population level, around in community members around the index case. So the infections around index case are more diverse than the infections are around controls. When all infections were considered and when we compared genetic relatedness between infections detected within a household and between households, we have seen a strong genetic relatedness between infections that were detected within a household than between households. Whether these infections were detected within the same investigation unit or between different investigation units. And when you look at the relatedness across distance between infections, you see relatedness between infections within a household, and it decays immediately when you go out of the household. But we see some infections as outliers. So here we did further analysis on these infections, the outliers, the further infections, but we show genetic relatedness with the infections within the households. And then when we put them in a time scale, we found that these infections, the outliers, have been detected in a short time period. So they are related temporally, even if they are not related spatially. So what you see in here is we divided the study area into 12 by 12 grids based on each grid is 1 kilometer based on the maximum distance over which most of the infections were detected. And for each grid cell, we calculated the ratio of the number of highly related infections versus the number of expected connections. By correcting it to the number of infections within the grid and also the location of the grid. It was corrected for that. And we found, and the red is indicating a higher relatedness connection than expected, and blue is indicating lower than expected. So you see some infections are related to each other, and this is also beyond the household level clustering. So you can get a detailed data when you use genetic tools. So we found fine scale grids with focal transmission of genetically related infections. The other important finding in this study was we found a unique subpopulation in the RCD arm compared to the control arm. 3 genetically distinct parasite populations were identified. What you see in the left side in here are the controls and the index case in the right side. And the yellow population was detected mostly in the index case. And there was only one infection which had the yellow population in the in the controls, but that infection showed a very strong genetic relatedness with one of the index case. So there is a unique subpopulation in the index case which may be driving the infection. And when we see the number of days, the median number of days over which these infections were detected, the yellow population, the unique one, was detected within in short time period, which is significantly different from the time of detection of the other two subpopulations. So with this, I would like to conclude my talk. And we detected clustering of Plasmodium falciparum infections around index case, and both species around RDT positive individuals. Infected individuals located around index case had more complex and diverse infections, and genetically related infections were identified within households, and this declines with the space and time. And within a household, and fine-scale focal transmission was identified, and this is an evidence for RCD-based detection. It can capture transmission-related infections as opposed to those related due to shared risk factors. And we may need to revise the radius of RCD based on local context, based on transmission intensity and logistic. And parasite genotyping, as indicated in the last slide, identified hotspots of focal transmission beyond the household that was not detected using the case clustering data. And I would like to thank the study participants and family members for their patience to participate in the study, and also my supervisors, Ton Bausema and his group in Nijmegen, and Chris Drackley from London School, and Sophonias and Brian for the genotyping work and data analysis, and also Christian Kufli from Notre Dame, and colleagues from Armor Hansen Institute and Addis Ababa University for contributing in the field work. And thank you for your patience.
Thank you. This paper is open for discussion or clarification. Jillian?
Hi. Thanks, Fitsum, for a good talk. I'm Jillian Stressman from London School, and I just have a quick question about the role of transmission intensity. And do you think that these findings would be consistent at lower and higher transmission intensities, or is there going to be like a threshold where you start to kind of see this clustering?
We have done this study 2 years ago, and we have an ongoing study this year recently, and then we see that the same. There is like a lot of decrease in malaria incidence in the area, which we cannot explain with whatever kind of measure being taken in there. Like in this slide, I showed 22% qPCR positivity, but this year we get only like 8% or 9% maximum. But the trend is still the same. So you find infections like around index case.
Thank you.
Yeah.
Fitsum, I had a procedural question about the reactive case detection. Given this, what's the recommended timeliness you'd suggest that programs should aim to complete that within?
Based on the results of this study, it's very difficult to make a conclusion on this. We have done our study, like within 2 days, the index was identified. We go to the community and screen the neighboring individuals. But we have had another study where we have checked infectivity to mosquitoes, and we screened 500 people, and we went back to the community within 2 weeks after doing a PCR. And then when we went back there, and there was like a lot of variation in the positivity and parasite density. Some infections cleared, some infections become high density, and even contributed for mosquito infection. So it's very difficult to conclude from this data.